Question number 18. A particle of mass m is attached to the end of a rope. Okay, attached to the end of a rope. The object is rotated in a horizontal circle. Okay, it's rotated in the horizontal circle, right? The end of the rope, which is increasing speed. Now you are increasing the speed. When you increase the speed, what can happen? The particle starts moving until, okay, the rope doesn't break off. The rope breaks. Okay, it breaks also when the angular velocity omega is reached. What combination of mass and angular velocity will this rope break? Now let us write the free body diagram for this. What is the free body diagram? This is the tension. So tension should be equal to m omega square r. I have converted v equal to r omega in the expression. I would have written this as mv square by r. I would have written this as m into r square omega square divided by r, thereby resulting into this expression. Okay. Now this will break when this condition is satisfied. Okay. If the value of t is larger than this value, definitely it will break. If it is lesser than it, it will not break. That's the condition. So the condition is if t is greater than m omega square r, it will break. This is the condition. Now let us see for each of this whether this condition is achieved and from in case which case does it achieve. Now here what will happen? T should now be equal to 3m into omega square divided by 4 into r. What will happen here? So this will be, pull myself here. So this will now be equal to 3m omega square r divided by 4. That actually I need m omega square r, but it's 3/4 of it. So definitely this condition will not break the rope. Then this one. So what will happen here? This will be t is equal to 4m into omega square divided by 16 into r, omega by 4 whole square, right? So therefore this should now be equal to, so 4 1s are 4 4s are, which should now be m omega square r divided by 4. So this will also not break the rope because t is lesser than m omega square r. Okay, the condition is that it should be greater than it. Okay, if t greater than m omega square r, only then the rope will break. Okay, so this condition is not seen here. Then let us look at this condition. T is equal to 3m into omega square by 16 into r. So what will happen? So this also 3m omega square r divided by 16. Here also it will not break. So let us look at this condition. So definitely this condition should be correct. If you want, you can verify this also. T is equal to 4m into omega square by 4. So multiplied by r. So this should now be equal to m omega square r. If either, okay, t is equal to m omega square r, it breaks, or if it is greater than it, also it will break. So therefore this condition is met only here. So D is the right answer.